your NCERT. So let's understand what we mean by lever. तो लेवर को जानने से पहले, लीवर नहीं है, लीवर बोलते हैं, लेवर बोलते हैं, कोई लेवरेज, get leverage out of this deal. So it's a simple machine. What we will try to understand something called a moment arm. पहले इसको समझते हैं. What is a moment arm? Okay, what is a moment arm? To understand a moment arm, so let me make out one diagram, so it will make it easier for you to understand. Okay, so let's say, and I have my axis. Okay, one minute, bachcha. So let's understand what is a moment arm. Okay, so what I'm doing out here is that, let's say we have hexagonal nut. This is a hexagonal nut. Do you know what is a nut? A nut. Okay. So we are supposed to open this nut. So what we are doing is that we will be using a spanner. So let's say how our spanner will be gripping it. Our spanner will typically grip it in this manner, in this manner, this manner, this manner. And this will be our spanner, right? ये हमारा spanner है, and with this spanner, with this spanner we are trying to open this nut. So how will you open this nut? Obviously we turn it anti-clockwise. So I'll be moving my spanner in this way. Force कहाँ पे देंगे हम spanner के ऊपर? So we will be applying a force, and the force will be, say, acting in this direction, right? I'm trying to open this nut, so my force is acting in this direction. Now, say suppose this is again a part of a wheel. Okay, इसको एक wheel का part बना लेते हैं. आइए. So let's say that the bigger picture is that, that we have a wheel. So इसको हम wheel बनाते हैं, and this is one of the 4 nuts of a truck's wheel. Have you understood? So I got 4 nuts. So lock nut 1, lock 3, 4. 4 nuts are there. This is one of the nut of the wheel of the truck, and you're supposed to open it. Now truck's nut means it will be very, very tight. You can't expect with that small spanner to open it. So if you see, the trucks will have somebody which is known as the handyman or khalasi, जिसको हम बोलते हैं. Hey, ja, nut खोल. The driver will tell him. So every truck will. One minute. Huh? Hello? No. Okay, right. So what we will do in this case is that every car cleaner will have something which is known as, he will carry a very large pipe with him. हमेशा हर truck में रहता है. So though since it is not opening, what he does is that he will have a pipe का टुकड़ा, and he will insert this pipe on this spanner. Very common practice. Okay, and then because trucks are very, very tight, so suppose he has to tighten it. Tighten means which side we will be giving our force? On this side. So the truck driver will that boy will actually stand on this. Common scene है highway में, आप देखोगे ट्रक का जब नट खोलता है ना, हाथ से नहीं खुलेगा. Nowadays you have mechanical ratchets, घुसा के खोल देता है, but manually इसको खोलना उतना आसान नहीं है. Suppose he has to tighten it, he will put that spanner, then he will put one pipe inside it, and then हाई करके ऐसे करके टाइट करेगा. ऐसा वो क्यों करता है? ठीक है ना, ऐसा वो क्यों करता है? Let us understand that story. Okay, say initially, say I'm not drawing this, say I'm removing this guy, and let's say this guy is trying to open this nut. then this guy would have, the nut would open very easily for him if he now applies the force at this end of the pipe. Okay? Now understand one thing. You are a human being. The effort that you apply is ultimately limited, है ना? Everybody has a defined amount of muscular strength. इससे ज़्यादा तो आपके पास है नहीं. But this is very tight. You still want to open it. So what do you do? आपने पाइप घुसाने के बाद जब आप यहाँ से टाइट करते हो ना, आराम से खुल जाता है. Is it that God blessed you with more stamina in you? No, you have the same strength. What you're playing with something, what we call in physics is called the word called moment arm. Moment arm is actually the distance, right? The moment arm is the distance from this particular axis of rotation to the point of application of the force. Now see, the first time the moment arm, without the pipe, the moment arm that was available to you was, say, this much of moment arm was available. This was, say, the moment arm with only the spanner, RS. In the next time, the moment arm that is available to you is this much. When is the moment arm more? You tell me. This is RS plus the pipe ka tukra. RS plus P. So, to open it, we need something which is known as torque. Torque is arm into the product of force and the arm. So here, moment arm is given by the force or the effort that you are applying multiplied by the arm length. Multiplied by the arm length. More is the moment arm, the more easier it will be for you to open this particular nut. In the first instance, effort is fixed. मेरे पास इतना ही ताकत है. I was multiplying with how much? Say 3. Now I'm multiplying it with 7 or 8. Has the product increased? Yes. So if you see doors will always have their knobs on one side of the door. Say suppose this is a door and this is the hinge. If you apply the doorknob out here, it will be very difficult. Can you close a window right from holding the window near the hinge? No. But imagine this is a refrigerator. Why are we giving the handle on this side? Because the moment arm is very big. The bigger the moment arm, the easier it is to open something. Agreed? It changes the, but this is not a, this is, we are trying to study this concept called moment arm. जितना बड़ा moment arm होगा, उतना काम करने में आसान होगा. If you would have given the knob of the refrigerator's door out here, it will be very difficult to open it. This was an example given to you to understand that more you increase the moment arm, the job becomes easy. Tomorrow you are unable to open a nut. Sometimes you have got a small nut which is very tight. A small nut will have a small spanner. The small spanner is not allowing you to grip properly. आप उसमें एक पाइप का टुकड़ा घुसा के फिर घुमाइए, एक बार में घूम जाएगा easily. Have you understood this? Or sometimes people do much more interesting things. Say sometimes you have got a ring spanner. Have you seen a ring spanner? Ring on both sides. They'll fix the ring on one side of the nut, other side ring is free. You put one screwdriver and you turn it, it will be easily opening up. जबकि आपके हाथ से नहीं खुलेगा. Right? Now we are in our position to understand what is a lever. ठीक है? अब हम ले, because we have understood what is moment arm. Clear? Moment arm is the force that you apply. Your application force is known as an effort multiplied by the length of the arm. What is the arm? From the axis of rotation, as far as you go, more it will be easy for you to do the job. That's why the truck driver was now he wants to tighten it. So he wants to put more and more effort. Nahi, he can't put more effort, more and more torque. To put more and more torque, his effort is limited. He has increased the arm and is now dancing on that and is pressing it with his leg. He और ज़्यादा tight होएगा. Clear? चलें आगे. Now we understand what is known as a lever. Okay, आइए जाइए. So a lever is a simple machine, and let's see where a lever works. Okay, देखते हैं. A lever is any sort of a rod. It can be a rod. It can be a pipe का टुकड़ा, whatever it is. Let's say we have a rod. ऐसा एक rod है, long rod, right? And say just take this rod and I twist it. Okay, fine. I have twisted it, and then I have some large mass which is very difficult to move. Let's say, let's understand that. Okay, let me make the ground level also. That will be easier for me. So this is my ground level. ठीक है? And right, this is my ground level, and I have a large mass. And say the large mass is there was a landslide and a big piece of boulder has actually fallen. I need to remove it. That is ground level. This is the ground level. वो रॉड है, लिखेंगे हम सब लिखेंगे, ground level है. And then in order to do this, we will take another stone or whatever it is. But I'm trying to draw it in a manner in which it makes sense to you. So let's say we will have another stone or another object. सीसॉ जैसा, ठीक है. तो ये टिपिकली हमारा लोड है. दिस इज द लोड. It's a huge boulder which has fallen off from a landslide. You do not have the physical strength to move it. So what you did, you actually brought a piece of rod, and you have seen that it is placed in such a way that you are able to peg it inside. आपने peg कर दिया, and you place another stone here. This is typically, children, you may say, sir, where did you get this triangular device? This is not a triangular device. It is also some sort of a stone that was lying, but this stone was having a sharp edge like this, right? I put it. And now what you do, now what I am doing, since I am the human being out here, right? I am applying what you call, I am applying the effort on this side. I am applying the effort on this side. अब क्या होगा? The lever will be actually, the lever is always able to rotate on this particular point. Understood? You kept the rod, so the rod can rotate on this point. This rod will be able to lift this load. Basically, you are playing the game of a seesaw, right? So let's see what are the names. This particular item with the knife edge point, this is known as the fulcrum. This is the fulcrum, and this is the lever. This is the lever, right? A lever is a rod or a bar which is able to rotate on a point which is known as fulcrum. The lever is able to, the lever rotates over a fixed point, and this fixed point is known as the fulcrum, which you will be creating with some object or whatever. You need a fulcrum. अच्छा, बचपन में आप, if you have a younger sibling at home, you will see when your mom makes his baby food, Cerelac का डब्बा, चम्मच अंदर घुसा के कटक करके डब्बा खोलती है ना. So your mom is also pegging one lever, and the fulcrum is actually the dabba's edge, and she's pressing on that. टक करके खुल गया. That's how we open achar dabbas and all. So this is my load, and we find that and on this side I will be giving what, beta? I will be giving my effort. So since it is a mechanic machine, the mechanical advantage has to be increased because we don't have the power to lift this load. So we should be making it a force multiplier. Yes or no? So now we will see the mathematics of it, how to make it a force multiplier, so that with lesser effort we are able to move this load. Is this understood? So let's can I change this diagram now? This is just to make you understand how a lever works. So a lever is a bar, a strong rigid bar, which is actually able to rotate over a fixed point, which is known as the fulcrum. The fulcrum is fixed. You can move the fulcrum. ठीक है? क्या तुम पीसी में क्या देख रहे हो? हाँ, so it is able to rotate on a fixed point, which is known as the fulcrum. And as it rotates on the fulcrum, with a lever, you can apply a lesser effort to move a larger load. Understood? So let's see this in easier diagram. What is happening? Okay. So let's say this is my lever, right? And on any fine day, let's say this is my fulcrum. This is the fulcrum, right? And this is right now balanced like a seesaw. It is balanced. Balanced means you have lifted the load out here, and you have also applied force out here, right? The load will be actually giving its force down. Load नीचे आना चाहेगा. The load wants to come down, beta. So let's see how the load will be positioned. The load wants to come down. This is my load, and you are also applying effort downwards. So this is how your effort happens. And right now you are balanced. Effort, this is fulcrum, and this is, sorry, ulta likh diya na. Sorry. This is load, this is fulcrum, and this is your effort. Right now you have lifted the stone in such a manner that you have made it horizontal with the ground. Bolo. This is E. Right? So this is your effort. Chalo, no confusion. This is your effort and this is the load. Is this much clear? Load wants to come down, but it don't allow it to come down by applying an effort. And you have made it horizontal. When you make it horizontal, then this part is also an arm. We call this as the effort arm. Let's say this is RE. And on this side also you have a force. And this is that particular axis. So this side we will call the load arm. And let's say this is represented by RL. Do you agree? Since you have been able to balance both the sides right now, your effort arm must be equal to your load arm. That's the reason it is balanced. Your effort arm must be, and just think like a small kid. If you have a seesaw, then you will make if your boy is very what you call lighter, the lighter boy has to sit at a much more greater distance, and the heavier boy will be sitting in a nearer distance. Yes or no? Then only there is a chance. If they are equal, then you can keep it at midpoint. But you have skewed it on one side. So now you expect your lighter boy to be on that side because the product has to match. So if this length is 3, the boy is 2, 6. And here if the length is 2, the boy should be 3, 6. So this is balanced. So under balance, we can say that the moment due to the load should be equal to the moment due to effort. Do you agree or not? If you look at the effort, if you just look at the effort moment, then you apply your common sense. The effort moment is trying to twist it on this side. Yes. So we call this as the moment due to the effort is known as the clockwise moment. And if you see the load arm is trying to twist it this side. So the load arm moment due to the load is always known as the counterclockwise or the anti-clockwise moment. Children, in a lever, once it has been balanced on the fulcrum, the clockwise moment must be equal to the anti-clockwise moment. Or we say sum of both the moments should be 0. Means if you bring this moment on this side, say if you take the clockwise as positive, the anti-clockwise is negative. Or if you take the anti-clockwise as positive and you bring it on this side, then it will become what? Minus. Algebraically, I can say load moment plus minus effort moment is equal to 0. So sum of the moment on both sides should be equal. So let's make them equal now. If I see this is the load multiplied by the load arm should be equal to effort multiplied by what? Effort arm. Are we clear? Then I try to bring the ratio of load over effort. So what is it? RE by RL. Agreed. And what is this ratio? Mechanical advantage. You have no control on these two. This is limited. So if you now want this ratio to go up, what will you do? You will increase the effort arm. You will increase the effort arm, na? That's what you did in the previous example. You increase the effort arm. Did you understand? It's very easy. समझ में आया कि नहीं? This should be equal. That means L over E ratio has to be increased. L is not in your control. E is not, you are limited with E. So you increase this ratio by what? By using the RE-RL ratio. So if you increase the RE, your mechanical advantage will increase. Therefore, if your mechanical advantage increases, your machine has now become a force multiplier. Therefore, with less effort, you will be able to lift more load. Online, have you understood this funda, how this works? Right. So whenever lever example, I didn't see any examples worked out numericals in NCRT, but in ICSE we have many examples. So here, whenever we do a problem, they say, suppose they will give you what is this distance, what is this load, and what is this load, at what distance should the fulcrum be pegged so that you are able to balance it. They will say that the lever is 1 meter lever. 1 meter means how much? This from here to here it is 1 meter. Find the fulcrum point so that you are able to lift a load of 500 kg. I don't know. So I say, let this much be equal to x. Then this is how much? 1 minus x. And this weight is given. This weight into x should be equal to your, and the boy has a limitation of applying only say 20 Newton. 20 Newton into 1 minus x. We equate them. Then we'll get the value of x. So once you get the value of x, you put your fulcrum there, आपका load आराम से उठेगा. समझ में आया? Very easy. But what they discuss more in this is रोजमर्रा की जिंदगी में कितने तरह के लेवर्स हम देखते हैं. ठीक है ना? हो गया, ये समझ में आया? Numericals आपके होते हैं ही नहीं. I did not see. If there are numericals and they make you do let me know. Now we see class of levers. This is what is interesting. Class of levers. Right. Therefore, they say, when you, in English, we have a term, when you go to any of the discussion, negotiation, you know what is negotiation? Some price negotiation is going on. There is a lot of leverage here. Lot of leverage means he's actually doing the discussion with lot of leverage. This is how we use it in English. बहुत leverage है उसके पास. Shift करो, थोड़ा और कम करने बोलो. Try to get a leverage of the situation. Means there is some advantage at your side. Use it. This is how we use it in English. अच्छा चलिए इसको देखते हैं. क्लास ऑफ लेवर्स क्या क्या क्लास होते हैं? लेवर्स आर ऑफ 3 टाइप्स. द फर्स्ट वन इज नोन एज क्लास 1 लेवर्स. क्लास 1 लेवर्स आर दोज लेवर्स इन विच द फल्क्रम विल बी, जो फल्क्रम है ना हमारा, फल्क्रम विल बी ऑलवेज इन बिटवीन द लोड एंड द एफर्ट. Most common type of levers, fulcrum will be between, means it will not be at the midpoint, but it will be in between. In such a case, load will be also acting on this side, effort will be also acting on this side. Can we see some examples? Well, we can see some examples. Seesaw is a class 1 lever, but let's say rozmara ki zindagi. Let's say you try to see something like say you have scissors. Again, the same example. You have your scissor, right? You have that scissor. Yeah, can you show me? अभी नहीं है. अच्छा चलो दूसरा एग्जांपल देखते हैं. Pliers. Pliers. Have you seen a plier? A plier will be typically like this. Another side is like this, right? And this will be like this, and this will be like this. Where do you hold the load? The load is held here. This side is where you apply the force. Look, if you are applying the force on this arm, this is your fulcrum, and your load, whatever nut or something that you have kept out here, this fellow will be trying to go on this side. You know, this arm is connected to this side. It wants to go up. So the load will be trying to push down. This is load and effort will be on same direction. Pliers. Scissors. With scissors, when you are cutting something, this finger is linked, the bottom finger, top finger is linked with the bottom arm. And the bottom finger is linked with the top arm. Effort is on this side. The scissor blade wants to come on bottom, but how the cut is happening? Because the load wants to come on top. Then only the cut will happen. Got it? Human body, the nodding of the head. Look, I'm showing. If I want to raise my shin, I have to put my head down. You put your head down. At that time, my shin wants to come down because my shin wants to come down. To lift the shin, this is force downwards. I am also applying a force downwards. So this is a class 1 lever on the human body. What all are examples of crowbar? जो पत्थर निकालते हैं हम ऐसे. Spoon used by a class 1 lever. Class 1 levers are pliers, scissors, nodding of the head, that is in your skull, nodding of the head. वो human being में बहुत सारे ऐसे example हैं. So in class 1, fulcrum will be always in between load and lever. Got it? And क्या हो गया, मुंह ऐसे बना के बैठे हो, क्या कोई भी इंटरेस्ट नहीं आ रहा है? So load and effort will be acting on same side. Class 2 sort of levers. In class 2, no, it's nothing like that. The load will come in between. The load will come in between. Sorry. The load comes in between, right? The effort is on one side and the fulcrum is at one end. ये है क्लास 2 टाइप ऑफ लिवर्स. ये तो मैकेनिक्स की इंटरेस्टिंग है. इसको हम कहते हैं क्लास 2. लोड विल कम इन बिटवीन. जरा देखते हैं ऐसे टाइप के लिवर्स कैसे हैं. लेमन स्क्वीजर देखियो. लेमन स्क्वीजर. The fulcrum is here. The effort arm is here. And the lemon or a nutcracker, you know nutcracker, which is cracking the nut is here. So if you are applying the force on this side, then the nut will be applying the force on this side. तभी ना वो crack होगा. Nut cannot have it on the same side. Are you getting this thing? And if this is applying an effort on this side, the nut is applying. Lemon squeezer, nutcracker, these are all known as type 2 lever. Wheelbarrow. Have you seen a wheelbarrow? So no, you don't take a wheelbarrow like that. A wheelbarrow will be something which will be grounded on the floor. That's your fulcrum. And then you lift it. थोड़ा सा उठाते हैं. If you see have British movies of old days, debris clean करता है ना ऐसे ले जाके. Have you seen a wheelbarrow? A wheelbarrow will be ऐसे रहेगा. There will be a portion which will be pegged on the road and ऐसा, और यहाँ पे एक wheel रहेगा, and there will be a handle here. So you will actually raise the handle. The load is here. The fulcrum is here. Right? और ये चीज actually joined रहता है. Sorry, it's joined like this. The fulcrum is here. The load is here, and the effort is here. This time fulcrum has shifted to the extreme right. Load has come in between. Wheelbarrow का डायग्राम ठीक से नहीं हुआ ना. आओ पहले एक wheelbarrow ड्रॉ करते हैं. कोशिश करते हैं. ये रोड है. wheelbarrow टिपिकली ऐसा होता है. wheelbarrow will be typically like this. So this is your handle, which the man will be holding here, right? And you will have a bucket like this, the bucket, और यहाँ पे एक wheel रहेगा, या फिर bucket में wheel लगा दो, जहाँ भी wheel लगा. ठीक है. ये ऐसे रहता है. जब भी आपको व्हील बैरो को लेना होता है, आप इसको ऐसे उठाते हो. So and then you push it. So your effort is here, fulcrum is here, the load is here. Load wants to come down, effort wants to lift it. व्हील तो स्लाइड करने के लिए है. व्हील तो स्लाइड करने के लिए है. आप व्हील बैरो की जगह चेयर ले लो ना, डाइनिंग टेबल चेयर. हाउ विल यू टेक अ डाइनिंग टेबल चेयर? उल्टा कर दो इस चेयर को. ठीक है. Now how will you take it? This is your fulcrum and this portion is becoming your load. यहाँ पे बच्चा बिठा दो. Otherwise, if I don't give this effort, load will pull it down. समझ में आया? यही चीज हमें दिखने में मिलता है in lemon squeezer, nutcracker. Fulcrum has shifted on one side. See, between class 2 and class 3, it's very interesting. In class 3 also, fulcrum will be on one side. All you are doing is you are shifting the fulcrum. Class 1, fulcrum will be always in between. It's not necessary that it should be in middle. It will be in between. If you see class 2 and class 3, fulcrum will go on either side. The swap will be between what? The swap will be between effort and load. See, there is one more example. Let's say this is the ground level and this is your toe and you are trying to, and this is your leg. When you try to go up like this, right? Up like this, you are putting your effort on top, whereas the body weight is working here. This is your body weight, which is the load. This is your effort. This is the fulcrum. This is a human body type 2 lever. Every time you wish to go up, you are lifting yourself up. Where is the fulcrum? Right on my toes. But the body weight is coming down. Body weight is acting downwards. Class 2 type of lever. Clear हुआ class 2? Clear? ये आपके इसमें है इन योर एनसीईआरटी, नो फर्दर सेक्शन में है, तो मैंने सोचा ये पढ़ाना चाहिए। एंड द लास्ट वन इज नोन एज क्लास 3. Class 3 type of levers are very stylish. In class 3, we will have, say, fulcrum on either one end. Say this side is fulcrum. Load will shift here. The load will be shifting here. So the load wants to come down, and the effort will be anywhere in between. Effort will be anywhere in between. Let's see an example. Tweezers. Let's say you have a tweezer or a forceps with which you are trying to hold one शुगर क्रिस्टल. उसका फलक्रम कहां पे रहता है? यहां पे रहता है, राइट? योर एफर्ट इज ऑन दिस साइड. अगर यहां पे आप एफर्ट दे रहे हो, द शुगर क्रिस्टल इज गिविंग एन एफर्ट अपवर्ड. और चपाटी दैट यू होल्ड, द चपाटी होल्डिंग टोंग, इफ यू सी द चपाटी होल्डिंग टोंग, इट्स अ क्लासिक एग्जांपल ऑफ अ क्लास 3 लिवर. फलक्रम इज ऑन दिस साइड. ट्वीजर इज अ क्लास 3 लिवर. अच्छा, सी this, the best part is, don't know how nice would be my drawing. Let's say your hand, elbow. Elbow is a class 3 lever, classic form of. We will have load. Load wants to come this side, and you lift something. You're lifting something. So the effort is always on the arm. Fulcrum is out here. Class 3 lever. ये एग्जाम्पल ज्यादा इंपॉर्टेंट है, कौन सा क्लास 3 होता है. तो डोंट पुट अ नट क्रैकर एज क्लास 3. Class 3, load will be always at the end. Sir, can you give some example? Tweezer, forceps, not tongs. Tongs में crossover है. Wherever you have a crossover, like typically we have that kitchen tong. Have you seen the kitchen tong with which you are taking out things? Kitchen tong is not a class 3 lever because in kitchen tong, the fulcrum is in between. Kitchen tong is like a, what you call, किचन टोंग मतलब बेटा मैं इसकी बात कर रहा हूं. ऐसा एक होता है ना औजार आपके मम्मी के पास, जिससे शी विल बी होल्डिंग द हॉट चाय का पत्ती. दिस इज अ टोंग. दिस इज क्लास 1 लिवर बिकॉज द फलक्रम हैज कम इन बिटवीन. दिस इज लोड, दिस इज एफर्ट. ये क्लास 3 नहीं है. क्लास 3 इज दिस वाला विच योर मॉम, चिमटा, विच योर मॉम यूजेस टू होल्ड chapatis. Because here the fulcrum has come here, her effort will be here, and the chapati is the load which is here. Class 2 is उल्टा हो जाएगा. Class 2 में fulcrum हमेशा इस साइड रहेगा, right or left whatever, and here is the nut, and you want to crack it. So the effort will be here, the load will be here. I hope you are clear now. So class 1 lever के examples क्या क्या है? Anything which is a crossover tool. Seesaw, garden, hedge trimmer. Hedge trimmer, you know, the long scissors with which people trim their hedges. Scissors, pliers, tongs, kitchen tongs. Don't use the word forceps. Okay, come to class 2. And in human being, what is class 1 liver? Nodding of the head. Class 2 liver, human example, raising your body weight on your toes. Toe is the fulcrum, ankle is causing the effort, and the foot is actually the load. What are other examples? Nutcracker. Fulcrum toe है ना, toe के भरोसे खड़े हो रहे हो ना, आपकी बॉडी ऐसे toe. Fulcrum is on which the load will dance. Anyway, nutcracker. फिर आपने सुपारी काटने वाला टूल देखा है? There's a, जिसको हिंदी में सरोता बोलते हैं. There is a device, सुपारी, you know, पान के साथ जो खाते हैं, betel nut. There's a betel nut cracker. If you go to villages and all, you must have seen, Nitya, betel nuts. You know what is a betel nut? Are in puja with pan, you give one round stick. That is called a betel nut. Supari. You know, that comes like a coconut shell type of a thing. As a raw fruit, it will just look like a baby coconut. So how do you deshell it? You have a apparatus which they will be using, which will have a, they are very nicely shaped. It will have a blade circle like this. There will be a blade and another portion like this. And people design it like peacock and all. They will put the betel nut here. Kancha. Are Telugu ladies most commonly use such an instrument for making avakai aam ka achar. When you are making on large scale, then what are your life skills? If you go, no, cut it. Don't. I'm not saying the knife. I am saying there is an instrument with which large scale, if you go to Raitu Bazaars and all, and you don't have the time to cut all mangoes, but you want to make achar, they will sit with so much of ripe mangoes and such tools. Kachak, 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 slice the mangoes and keep it. Because when you make achar, you want it with the seed, right? Such sort of a tool is used. Go and ask your mom. And in large scale usage, they have got legs also. So the lady will be sitting, and it will sit like a small peacock on your floor, and she will take mangoes. Kachak. How many mangoes can she slice? They will be slicing some 500, 600 mangoes at a time. ये है क्लास 2. क्लास 3 में लीवर एक साइड में होगा, एफर्ट बीच में आएगा. ट्वीजर्स, फोर्सेप्स, किचन फोर्सेप्स. टोंग वर्ड यूज मत करो, कंफ्यूजन. फोर्सेप वर्ड यूज करो. फोर्सेप्स. टोंग मीन्स देयर इज ए क्रॉसओवर. टोंग बर चिमटा. चिमटा इज द बेटर वर्ड. सो बेटर वर्ड इज फोर्सेप्स, ट्वीजर्स. ठीक है, यही था लेवर्स में. If there's any question anyone wants to ask, still you have a doubt in classes of levers, because I believe you will get a question. If there is no numerical, they will give you 1 or 2 mark examples in which they'll say a nutcracker is a dash class of lever. So have you understood the funda or not? In class 1, the fulcrum will be always at between, and the load and the effort will be on the same side. But in the other two, the load and the effort will be always on the opposite side. Whether you are a class 2 or whether you are a class 3. Fulcrum always on one edge, the load and the effort swap between each other. Any questions that you would like, or any example you want me to say again, anything that you have not understood on mechanical advantage, because after this chapter closes. और कुछ है नहीं, इसलिए तो मैंने रखा था. Clear? Any question anyone online would like to ask? Sir, class 1, class 2, class 3. If you have understood, then very good. Rowing a boat क्या होगा बोलो तो? Rowing a boat. Where is the fulcrum? Fulcrum is the point on which the row will rotate, on which the lever can rotate. Load this side, effort is on this side, water also comes to come this side, you put up the water. Class 2 or 3 होने के लिए lever has to always move on one end. Chimta moves on one end, nutcracker moves on one end, my foot toe moves on one end, my elbow moves on one hand. These are all class 2, 3. In class 1, the fulcrum will be always in between. Always on between, जहां लीवर रोटेट करेगा. ठीक है, चलो.